Section 8.2.19. According to a study conducted by an organization, the proportion of Americans who were afraid to fly in 2006 was 0.10. A random sample of 1,500 Americans results in 165 indicating that they are afraid to fly. Explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has increased. Okay, so one of the requirements of this model is that the sample values must be independent of each other. When sampling from finite populations, we verify the independence assumption by checking that the sample size n is no more than 5% of the population size. Now the sample size, 1,500, is less than the 5% of the American population. Okay, now we want to determine the shape of the sampling distribution of the sampling proportion, which is approximately normal to the following formula. So what we want to be able to do is we want to find, okay, when n times p times 1 minus p is greater than or equal to 10. Okay? So let's go ahead and do that. So we have n in our problem is equal to 1,500. And we know that the value of p is equal to 0.10. So there is 0.10, and there is the value of n. So that we know that n now is 1,500. We're going to multiply that by 0.10 times 1 minus 0.10. We want to see if that's greater than or equal to 10. So we get 135, which is therefore greater than or equal to 10. So that checks. And so therefore we can say that since the sample size is less than 5% of the population, the shape of the sample distribution of, let's see here, that's going to be the sampling proportion, is approximately normal. Okay, now what we want to be able to do is we want to be able to compute the sample proportion of Americans that are afraid to fly. So for step 2, we want to compute the sample proportion of Americans that are afraid to fly. So what we need to know is we're looking for the sample proportion when we know that the value of x in our problem is 165, and we know the value of n is equal to 1,500. So in order to find the sampling proportion, we know that's going to be x divided by n, which is equal to 165 divided by 1,500, which gives us 0.11. Okay, now for part 3, what we want to be able to do is we want to be able to determine whether the sample proportion is of 0.11 is unusual. And so what we want to do is we want to find the probability of when x is greater than or equal to 165, which is equal to the probability of when the sampling proportion is going to be greater than or equal to 0.11. Because if a sample proportion of 0.11 is unusual, then any sample proportion greater than 0.11 is also unusual. Okay, so now what we want to do is we want to determine, okay, what is the mean of the sampling proportion? Well, if we go back to the beginning, we can see that it was 0.10 up here. So therefore, we know that that is 0.10. Okay, and then we also want to find the standard deviation of the sampling proportion. So that means that we know that that's going to be equal to p times 1 minus p over the value of n. And so we know that the value of p is equal to 0.10. And we also know that the value of n is going to equal 1500. So we're going to get the square root of 0.10 times 1 minus 0.10. We're going to divide that by 1500, which is going to equal 0.007746. So we're just rounding it to those decimal places. So now we know what the mean and the standard deviation is. Okay, so now what we want to be able to do is we want to find, again, the probability that the sampling proportion is going to be greater than or equal to 0.11. Okay, so if we have our bell curve, we know that our mean is 0.1, and we know that we're looking for the value to be greater than 0.11. So we're looking for that area. Okay, so for this example, we're going to convert this into a z-score. So right now, we're looking at the bell curve with the regular normal value. So what we want to do is we want to convert this into a z-score. So in order to convert this into a z-score, okay, what we need to know is the fact that the sampling proportion is equal to 0.11. We know that our mean is given as 0.10, and we know that our standard deviation is 0.007746. So using the z-score formula, z is going to equal the point sampling proportion minus the mean of the sampling proportion over the standard deviation of the sampling proportion. So that's going to equal 0.11 minus 0.10 divided by 0.007746. So we're going to get a z-score rounded to 2 decimal places to be 1.29. So now our z-score graph is going to look like the following. So now we want to find the probability that z is going to be greater than 1.29. So using our bell curve, now since it's a normal distribution, we know that this represents 0. And we're looking for the area to where it is greater than 1.29. And so here we can use a technology. So we're going to use normal CDF with a lower bound of 1.29 and upper bound of 9999. We know that since we're now converted this to a z-score, that we're going to use a mean of 0 and a standard deviation of 1. So let's go ahead and do that. Second distribution. So we have 1.29 as the lower bound, 9999 as the upper bound. We know that our mean is 0 and our standard deviation is 1. And so therefore now we're going to get our area or our probability. So the probability is going to be 0.985, rounding it to, maybe write that again, 0.0985, rounding it to 4 decimal places. And then if we wanted to do that on StatCrunch, then we know that the mean is 0. We know that our standard deviation is 1, and we want to find where it is greater than the z-score of 1.29. And if we compute, we can also see the area that's located there, or the probability. Okay, now let's go ahead and summarize this. So what this means with the probability of 0.0985 is that about 10 samples in 100 will result in a sample proportion of 0.11 or more. Using this information to explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has increased. Note that typically an event with a probability less than 0.05 or 5% is considered unusual. So again, this is not necessarily evidence the proportion of Americans who are afraid to fly has increased above 0.10, because the probability of obtaining a 0.11, because the probability of obtaining a value equal to or more extreme than the sample proportion is 0.0985, which is not unusual.